Hi guys, in this video we're going to look at numbers 9 and 10 from that 9.6 worksheet. You might want to take a second and pause and read through this problem, number 9, if you haven't already. Once you've done that, you can see that we have this plane trip which has two parts. If I try to draw a little picture that will demonstrate this, we have the first part of the trip at which we're going 105 miles per hour. For the second part of the trip, we speed up to 115 miles per hour. The only other information we're given is some total trip data. We know that the whole thing is 555 miles, and it's going to take us 5 hours. So that's what we can pull from the problem. What we're looking for is how long we're traveling, or what the time is for each of these trips, or each of the parts of the trip, excuse me. So if I slide this out of the way so we have plenty of room to do some work and still read that. Here's how this is going to work. Most of these problems are going to start with this formula, which I think you've seen at some point in your lives. Distance equals rate times time. If I use this equation for both of our trips here, the first part of our trip, our distance we're not sure of. We'll use the variable d to keep it simple. Our rate is 105 miles per hour, and our time, again, is what we're looking for, so we'll leave that for t. For the second part of our trip, we still don't know the distance, but since we know the total distance is 555 miles, we can write this part of the equation as 555 minus t. That's going to pull the distance from the first part of our trip, which will add up to our 555. That's going to equal, we know our rate is 115, and our time in this case, just like we did for distance, is going to be the total 5 hours minus the time for the first part of the trip. As you can see, what we have here is a system of two equations. There are many ways we could go about solving this. I think the best way, you may be tempted to substitute, but if we just add these two equations, the d's will cancel out right away. And we'll be left with, I'm going to write it over here, 555 equals 105t plus 115 times 5 minus t. If I distribute the 115 here, we get down to this point. The math works out pretty nicely from here. This is 575 minus 115t. When we combine like terms, we get negative 20 equals negative 10t. So t ends up being 2. That doesn't quite answer our question. It asks how long did the plane fly at each speed, so each part of the trip. The t we used was really from part 1. So we can say here that for part 1 of our trip, that took 2 hours. Since we know the whole thing had to take 5 hours, we can figure that part 2 was 3 hours. And that's it for our answer. That's what we were asked. So again, this equation up here, distance equals rate times time, we're going to use for almost all of these problems. And it's just a matter of taking the information you're given, usually eliminating one variable, or in some cases you'll know that the variables can be set equal to each other. But then it's just usually a system of equations in algebra through there. So that's it for number 9. Let's take a look at number 10. So we'll use the same strategy, for number 10. Let's start by again drawing that picture. So we're going from where? We're starting at home, and we're going to the airport, and then we're going to the office. So the first speed, we know we're going 30 miles per hour. From the airport to the office in the helicopter, we know we go 60 miles per hour. And again, we have some of that total data. We know we're going 150 miles total, and that we're taking 3 hours. The directions say find the distance from the airport to the corporate offices. So what we're looking for here is this distance. We're going to use again the similar strategy to number 9 to figure that out. So again, if I slide this out of the way, we're still going to use distance. My pen here, distance equals rate times time. We'll have part 1 and part 2. First part of the trip, the distance we're not sure of. The rate we know is 30, and the time we're also not sure of. Again, this is very similar to number 9. For the second part of a trip, for distance, we're not sure of that, but we know it has to be 150 minus the distance from part 1. It's going to equal our rate, which is 60 miles per hour. And our time in this case will be 3 minus the time it took for part 1. So we'll put that as 3 minus t. Now I'm going to attack this the same way. We're looking for d, so it may not make sense to cancel d, but a quick substitution using this equation will get us to d pretty quickly. So let's go ahead and solve for t. If the d's cancel, I get 150 equals 30t plus 60 times 3 minus t. So 150 equals 30t plus 180 minus 60t. Combine like terms, we get negative 30 equals negative 30t. So t equals 1. That t equals 1 is up here from part 1. So the time for part 1 was 1 hour. If we substitute that into this first equation, we know that the distance for part 1 has to be 30 miles. What the question asked us for, however, was the distance of part 2. Since we know those two distances have to add up to 150, your final answer would be 120 miles. And that again was asking us from the airport to the office by way of the helicopter. So again, very similar. We eliminated the variable we were looking for, but it was pretty easy to go back and solve. So I would choose whichever strategy is best algebraically and then go from there. Good luck on the rest of the sheet. We'll see you guys tomorrow.